and this will be helpful. Right. Okay. So what we're looking at, the title is cumulative frequency, but often for short just CF. So we're going to look at CF tables and CF graphs. Okay. So before we can do cumulative frequency, I need to give you a frequency table. So let's just start off with a frequency table. So this can be our X and this can be our F. We'll just make it 4. So maybe this X here is, I don't know, person's height or something. So this first bracket could be 130 to 139. And then 140 to 149, and then 150 to 159, and then 160 to 169, or something like that. It's not too important. So these will be heights in centimeters. So X is in centimeters. And let's say here we have 3 people, 4, 2, and 1. So there's nothing new there. That's just a frequency table. Yep. Now, suppose I was to ask you this. How many people are less than or equal to 139.5? So how many people are this height or less?
3.
How many people are less than or equal to 149.5?
4.
7, yeah. Because those other 3 people are also less than this height. And then likewise here, less than 159.5, 9. And then less than 169.5, 10. This here is called the cumulative frequency. And of course this one here is still just the upper boundary as normal. Okay, so that's our first example of a cumulative frequency table. And it's very common in the exam that they would say, add the cumulative frequency column to the table. So what they want you to do is to draw the table and then put this at the end of the table as extra. Although we don't really use the verb add. Does anybody know another verb here that means add? Like the stick on the end? Insert is okay, but insert could be anywhere in it. We need a verb that usually means at the end of something.
Sure.
No? No. No? Extend. It's a verb and it means put it at the end. So the meaning here is put a cumulative frequency column at the end of your table. Yeah? That's okay? Okay, so let's have a look now. Did you have these numbers written down? Because I want to put them in Office. You have them? Yeah? Okay, so the first one here is X and F. So what was the first one? 130 to 139. 140. Okay, so they're all the same, really. And then it's the last one. And then here, what do I have? Okay. Now here is my upper boundary, and that is 139.5. 149.5. Whoops. Oh yes. That's my mistake. Okay, and then here is the cumulative frequency, which would be this one and then it would be this one. Well, it'd be the sum of the first two. And then this one here is 9, and the last one there is 10. Okay, we can put these in a graph now. And the way we usually graph these is by putting this one here on the x-axis and this one here on the y-axis. Okay, this is how we graph it. So for example, the first point would be 139.5 and its height would be 3. The second point would be 149.5 and its height would be 7, and so on. So let's see, I'll get the graph here. So this is what I mean, it's like a line graph also. Okay. My first CF graph. And on the x-axis, what's on the x-axis here? Yeah, which in this case is what? What does the x represent? What did I say the x was? Height. The x is height. And the unit for height we were using? Centimeters. And the y is cumulative frequency. And there is no unit, it's just a count, 1, 2, 3, how many you have. Okay, so I think this is all good. Yeah, and this is what the graph looks like. Let me just shrink it down a bit. Now when you get this in the exam, you're asked to draw this, and you'll be asked to draw it on graph paper. So if you draw it on graph paper, it'll either be long and skinny like this, or if you turn the page the other way around. Like, well, no. Or something like this. Yeah. But most people, I think the question is, most people usually just go this way around. But anyways, it's not so important. I'll make it as big as I can, so it's easy to read. Okay, so how do we read this? So for example, if I go back to my table here, oh my goodness, 139.5, there are 3 people less than this height. 149.5, there are 7 people less than this height. So if I look here, 139, that's around about here at 140, and you can see that it is 3. So what you can do now is you could say, okay, how many people are less than, say, 165 centimeters in height? You can't do that here. Why not? Well, because you don't have 165 here. I could tell you how many are less than 159 or 169, but not 165. But if I go to my graph, you can see there's 165, and how many people are less than this height?
9.
Yeah, about 9. 9 people are less than this height. So this is why a cumulative frequency graph is useful, because then you can answer questions like this. But I need to point out some very important vocabulary. I have called it graph, and I called it graph on purpose. We don't usually call it graph. We usually call it cumulative frequency curve or cumulative frequency polygon. And there's actually a difference, a small difference between the two. When it's a polygon, you draw it like this, like a line graph, with straight lines between each point. But when they call it a cumulative frequency curve, you draw it like this, with one single curve that goes through them all. Please be careful in the exam. Make sure before you start drawing, you know you're drawing the right one. It'll cost you 1 mark if you draw the wrong one. So this one is called the curve, and this one's called the polygon. So here, these are all flat, and this is a smooth curve, like this. So we are clear on the difference here? Yeah? So if I go back to my example here, which of the two is it really? Polygon. So now I'll make the change to my title. Okay. Now let's do one. I don't think I can change it. Yeah, I'm going to do it now, and I'm going to do it as the curve. Curve. And again, its height in centimeters and its cumulative frequency and its count. Oh, for goodness sake. Sorry, I know what I did wrong. This one, this one, this one, this one. My first height in centimeters, cumulative frequency, count included. There we go. Shrink it a little bit. Now I know it doesn't look much different. In fact, it's not really much different, but it will change your answer a little bit. So here, what was my last one? 165, wasn't it? When I look here, it's almost like it's more closer to 8 than it is 9. It's not quite as high. Now you can't see it here because this is not graph paper. When you have graph paper, there'll be lots of little boxes here, and that you can't see it, so you'll have to trust me, okay? But in the exam, really, you need to be very neat here, because they'll expect your graph to be accurate to 1 millimeter. That's how accurate they expect. 1 millimeter. So, don't just go, nailed it, alright? Take your time doing it. Yeah, because it's easy marks. I think when they ask you to draw a CF, it's 5% of the time this one and 95% of the time this one. What do you think the reason is for that? There is a reason for it.
More accurate?
Yeah, this one's more accurate, and this one means that everyone should get the same answer because it's straight lines, whereas this one not the case. I know I was talking to Colin about this in biology as well for the graphs. So what does Colin currently say you should do? This one or this one?
For the smooth.
The smooth one, yes. Yeah. So for biology it's that, but I don't know if in the past it was more often this. Anyways, for maths we don't have to worry about that because the question will tell us which one it is. Okay, now we're going to have a look at what else we can use this curve for. So if I just go back up here. If there are 10 people, where would the medium be? Which person? Which position? In a group of 10, who is the median? Which number?
5 and 6.
5 and 6. So where is the fifth? Yeah, where's the 5th and 6th person here?
From 1 person to 1 person.
Yeah, they both are in this box here. Yeah. Although we can't really see where the 5th and 6th person is, because what would we like to have here? We would like to see 5, wouldn't we? Then we can know where they are, the 5th person. But that's why the cumulative frequency is useful here. What I can do is go to 5 here on my y-axis, go straight across to my graph, and go down, and the median is about 144. Why not? About 144 by using the graph. So let me show you how I did that again. You go to the middle. So what's the biggest number here? 10. You go halfway, there's 5, across and down. This number here is the median. And you can do the same thing to get the quartiles as well. So just to be clear, There's your graph, and let's say this is the maximum. To find the median, what you do is you go to the point in the middle, which is at 50%. So in this case, if I have 10 people, half of 10 is 5. We go across and down. This number here is the median. Likewise, to find the lower quartile, I could go from 25 across and down, and then to find the upper quartile at 75% across and down. Q1, Q3. So what I want you to do for me, using this graph here on the screen, I want you to try and tell me Q1, Q2, Q3. That is the lower quartile, the median, and the upper quartile. Once you have those, I then want the interquartile range. So try and just look at this and give me those numbers here. Estimate. Lower, median, upper, and interquartile range. Okay. You have that?
Yes.
So what do we think the lower quartile is?
139.
139. Yeah. And the median?
Median is 144.
About this, yeah. And the upper quartile?
Yeah.
I don't know about that last one.
The upper quartile is
Maybe I have to get too big.
155.
Hang on, where would the upper be? At what number? 7.5. So that would be about... yeah, I'd say so.
Why is it 7.5?
Well, if you have 10 numbers, what's 3/4 of 10? I will wait while you calculate on the calculator if you need to.
2.3.
No? 3/4 of 10. Yeah? 3/4 of 10 is what number?
0.75.
No, wait. We need confirmation here. What is it? And does your calculator agree? Okay. Who, do you agree? You agree, good. So if we go from 7.5 across and down, we can get our number. So what do we think it is about? I'd say about 152, 153. Yeah? Oh, Mark, come on. 153 about. Not what I'm talking to. Upper quartile 153. Can you make note? Okay, so now give me the interquartile range.
14.
What is it?
14.
14? Did other people get that? About 14? Interquartile, you don't listen to me. Q3, I said it's about 153. So the interquartile range would be 153 minus, and the
14.
about 14. You got that? Yeah? Okay. Can I delete this? Can I remove this graph? Yes. Right. data could I have? Do people know their height? Oh goodness. Okay, people know how many brothers and sisters they have, right? Yes, I would hope you know that. So, let's go, Lena, how many have you got? 3. Yusra? 5. 1. 5. 3. 5. Brothers and sisters, how many? 2. Brothers and sisters, yes, how many?
9.
You sure? Philip? Okay. Who?
2.
1.
2.
Okay. So what I want you to do with this data for me is, firstly, I want you to put it into a grouped frequency table. Now, first question, how many boxes should you have here?
The amount of numbers we have.
Sorry. Not grouped frequency, it's not necessary. You can just put in a frequency table, I guess. No, we can't because of, who's this 9 here? It's causing problems. No, you would have to put in a grouped frequency table, actually, because it's quite spread out. So, let's see. I'll just get the table started for you. How many numbers do I have here? 15. What's the square root of 15? Yeah, well, it's going to be 3 point something. So when I round it up, I get 4. So I should make 4 boxes. So here is my X, and here is my F. What is the smallest number in this data set? 1. And then the largest? 9. So the difference between that is 8. If I break this up into 4 boxes, how many is that in each box? It goes up in 2s, doesn't it? So if I go up in 2s, that'd be 1 to 3.
4 to 6.
1 to 3. 4 to 6. Well, actually, no, sorry. If I go up in 2s, I guess it's just, it'd be 1, 2, 3, 4, 5, 6, 7, 8. Yeah.
Because you're going to build the line, you don't know.
I don't mind. 7 to... That'll have to do. 7 to 9, and then here 10 onwards, 10 to 12. Or maybe actually I should start at 0. Yes, that would be better for me. 0 to 3. No, to 2. 3 to 5. 3 to 5. 6 to 8, and then 9 to 11. Now, there's no, it's your table, so it's not like it has to be exactly the same for everybody. Remember I said the whole square root business is only just guidelines, okay? Trying to help you make a neat table. I feel this is actually the nicest table I can make. It's not too far left or right, and it's, 4 boxes is enough. Anyways, here's my table here. Okay, so what I want you to do for me now is to fill in this table. So just put in the numbers in there. Here, let me make your lives a little easier. There now. Good, yeah? You drew your table? Show me. Yes, okay. Okay, have you done that now?
Yes.
Yep. Okay, so this one here, how many?
8.
Is it?
Really?
Next.
Oh, because the...
What is it? 1 and 1. Yep. Okay. Now, next we need our upper bound. So what's the upper bound on the first class? 2.5. Next one? Yep. 11.5. And here's my cumulative frequency. So here it is 7, and here it's 7 plus 6, and here it is 7 plus 6 plus 1, and here it is 7 plus 6 plus 1 plus 1. Okay, so this is your extension. So what I want you to do for me now is to draw the cumulative frequency polygon. I know who, you don't like this, I'm sorry. It's okay. Drew it? Show me.
My ship is really good.
Let's see what you got. You're right.
It's too small.
Yes. Anybody else?
Yeah, it's supposed to bend over, right?
Whoop. Huh?
Supposed to bend over this way.
Yes. Yeah, okay. Right, so once you have it drawn, I want the lower, the upper, and the median from your graph. Okay, do you have the tree for me? What's the lower quartile? What did you get?
3.7.
3.7. Anyone else got an answer for the lower?
No.
What did you get
3.75.
for the lower as well? It's kind of big, but maybe. What about the median? 4.5, 6. I think there might be some issue with our graph accuracy here. Let me... Hang on, I'll draw you a graph now.
No, it wasn't 10.
10! It's getting better. Sorry, further away. Right. So, if I have 15 people, what's a quarter of 15? 3.75. That's not the lower quartile. So, if I go... Let's see... Yeah, I don't have a line here is the problem. So I can't draw this in on my graph, but anyways, if I use my imagination, it will be nearly 2. Actually, maybe I can force a line in. Hold on. Now, actually, this is good actually because it brings up the question about do we go through 0, 0 or not. Okay. Now, think about this here. Siblings, yeah? How many people have 0 siblings here?
No.
No one. So, 0 and 0. And how many people could have less than 0 siblings?
No.
Could anybody have -1 sibling?
Like, you mean, passed away?
No, I don't. You know, not what I mean. It's impossible to have less than 0. So in this example, it is safe to include 0, 0 on the graph. But in this example, in some examples, not so. Again, what about that example of the height? Is it right to include 0, 0 for this graph of height?
No.
It is right. Sorry, you can include 0, 0. How many people have a height of 0 or less?
No.
Yeah, no one. Right? Come on, biology students. How many people have a height of less than 0?
No.
Exactly, 0. So I can include 0, 0 here. So let me include that. Colin will be so pleased at your biology knowledge. Next. I won't bother putting in the title. Okay, so now it's looking a bit nicer. So 3.75 would be about here. So what would you say the lower quartile is? About 1.5. Something like this. Okay, whatever. So write this down. Now what about the median? What do we think about for the median?
4.5.
What did you say? 4.5? So 15, 7.5... No. We're having trouble here. No, stop saying numbers, please. Listen, 15 people, what's half of 15?
7.5.
So if I go to 7.5, which is here, what do I get as my median?
2.6.
About something like this. So write that down, please. What is 3/4 of 15?
11.
So that would be around about here. And what value is that?
11.25.
4.3, we'll say. For the upper. What is the interquartile, roughly, what is the interquartile range? About 3.4, yeah? Okay.
I got 2.4. Me.
Who? Doesn't matter. Look, when I asked Excel to calculate it, Excel got 2 as the lower. Now, Excel can do this more accurately because it can use all the data. It's not doing it from a graph. But anyways, don't worry about that. It should be roughly 2. And what did we say? No, I thought we said for the lower is 1. Yeah. For the median, what did we say?
3.
And here it's 3. So it's a little bit further away. And for the upper?
4.9.
Whatever. Here we have 5. So for my one, Excel says interquartile range is roughly 3. Yeah? Now, some warnings. So when people draw this graph in the exam, warnings. When people draw this graph in the exam, they put their data here, and some people don't put cumulative frequency. What do you think they put here by mistake? They put frequency. So if you put frequency instead, what shape of graph will you get? Well, in this example, what would happen to the graph?
Go up and then down.
In this one here, what's happening? It will go up, yeah, and then decrease. Something like this. So this is the thing. This graph must increase. Why? Why must this graph be always increasing? Because we're adding. So it's impossible for it to decrease. Okay? So there'll be some person in this room right now, and they will do this question in the exam, and they will put frequency instead of cumulative frequency. And instead of their graph going up, it'll go up, and then back down. And this should have been a warning to them that they did something wrong. The graph must go up. And if they don't fix it, and they'll give it to me and they'll get 0. So the graph must go up. Don't use frequency, use cumulative frequency. If your graph looks like this, you did it wrong, don't give it to me. And you're all thinking, I won't do that. That won't be me. I'm sorry. There'll be one person. I can tell you who the person was in September. I can tell you who the person was last year. There will be one person in this room that will give me that. And they'll get 0.
The case.
Hmm?
You mean the case?
Yes, this. They'll give me this. And they will get 0. And it's not a difficult question, so they just wasted 5 marks, because you can get 5 marks for this. Okay? So if you draw this, that's bad. Don't do this, please. You know what it looks like. It should look like this. Your graph must always increase. It can never decrease, not even a little bit. It must always be increasing. Now, it could be flat. This is acceptable. But this is impossible. It must be going up, or at least being flat, not going down. So, I've given you a good warning, and it'll be interesting to see who will be this person who will make the mistake here. I have an idea. I'll let you know after the exam if I was right. Okay? It's going to be you. Yeah. Okay. Now, what we'll do is, I'll let you try a couple of these in the workbook and then we'll just do the next lesson. Okay, so just try these for a few minutes. I think if you have the choice between, well, I mean, do you want to just do the classes back to back and finish sooner, or do you want a break in between? What would you feel like?
Back to back.
Back to back? Yeah?
Yeah, back to back.
Back to back? Who's your class rep? Yeah. Oh, never do, Hugo's gone, you've no representative. No?
So she's the class rep and she agrees, so we have to go.
Back to back means finish sooner, yes. This is what you want?
No.
I tell you what, you can take a break and then when we all leave, you sit for another 20 minutes then. Is it okay?
Yes.
Great, okay, we'll do that. Okay, so try these for a few minutes and